Very good morning to 100% here. Today we are going to discuss about the views of the data. So as we know that there are so many different type of users, they are looking to access or trying to modify the database. So these views of a data, it gives a perspective to the each and every individual users, the different types of database users. Accordingly, based on their role, it gives a views to access the particular database. The meaning of the access in the sense they can modify, they can execute any type of transactions, as well as also they can modify the data which is presented in the database. That's right. So this is the purpose we want to see about how the database are viewed as a perspective of the each and every database users. As we know that earlier we have discussed about, we have three different types of the users and the database. One is called as a end user. Just they are trying to access and modify the data which are presented on the database. They are only looking on the certain part of the particular database, certain part of the particular DB. They are not looking on the complete the structure or the complete database. Say for a similar typical example, we have in our university we have a beautiful database, right? As being the end user, as being the one of the user, as a faculty, as I'm looking only on the student database, right? In this sense, I am the end user for accessing this database or modifying certain data on the particular database. Apart from this student database, other details, other databases are supposed to be hidden. I no longer need to access any salary details of the particular employee. Right. So likewise, every users who are associated on the particular database or on the applications, they are having a different perspectives to access a particular DB. Right. And next come to the system programmer or the application programmer. These application programmers are trying to access these databases by using writing some programs, executing certain programs to access the particular database. So when compared to this end user, this application programmer should have a high level of views about the particular database. And we have a DBA, database administrators. Now they supposed to know the complete structure of the database. Say for an example, another one, a typical example. Now, when I'm storing when I'm storing the student information, now all the student information is maybe stored onto the storage area in a particular format and the particular structure. As being the end user, I need not know those storage details. I need not be aware of those storage details. How the particular data is stored onto the storage medium and in what way it is supposed to be stored. But it's completely known by the database administrators. So for this purpose, every individual players, they are having their separate roles. So whatever the database or whatever the applications we are having, it supposed to give the different perspectives to the each and every players. So that's why we are going to discuss about the concept that is called as the views of data. Right? I think you are clear about what is the reason we are having a views. Right. Now let me come into a little bit deeper into the particular topic. Now generally there are the three levels of views are there. Right? One is a physical level view, and second one is a logical level view, and third one is a view level. Where, as I said, the end user is looking only on the part of the database, not on the entire database. They are trying to access and modify certain information only part of the particular database. Now that can be done with the help of the view level. Likewise, you all are also the end user. You are having a different perspective. You are also trying to access and retrieve some amount of a data or some data from the particular database. So this view is also having a number of subviews according to the user's needs, according to the end user's needs. Right? And the first level, that is called as a physical level. So this physical level, it deals about, or it gives the perspectives of the database administrator about what is the structure the database is stored, in what way the database is stored, in whether it is stored in a sequential way or in other different way. And this is a lower level. This physical view is a lower level of the particular database. Whereas this logical view it provides a higher perspective to the users about the particular database. It also hides certain information to the users, like say for an example, the storage structures, and other details to the users. Now, this, without affecting this logical data or logical views of the particular database, we can change the structure of the particular physical database. We can change the structure of the physical views, or we can change the structure without affecting the logical database. Right? Now let me go in depth one by one now about what we can do with the physical level databases, physical view, logical view, and a view level. Right. So as we know that the main purpose of the database, what is the reason in behind of I need to have three different levels of views, is because of the database, it consists of the various interconnected data, and every data is accessed through a set of programs. Now what the users are doing it here, since it is a collectively massive amount of different kinds of the data, now every individual user, they are trying to access the particular database, or trying to access particular data what they needed. So the main purpose of access is they are trying to retrieve certain data in an efficient manner. As already we said, a database, it have a complex structure. But when every individual user they are trying to access, it should have a convenient and efficient way to retrieve the particular information or a particular data, even though if it is a complex structure. Even though if it is a complex structure. So to reduce this complexity, and as far as to fast access and efficient retrieval of the data, we are having here the various levels of use. We are having the various levels of use. Right? The major purpose of the database is to provide the users with an abstract view of the data. It provides the abstract view, right? So obviously, when I want to have the abstract view, then definitely it's supposed to hide certain details, certain information, and certain portion of the databases to the various number of the users. Then only we can, every users who are associated on the particular database, they can effectively retrieve the information. They can on an efficient way, they can retrieve the information. How we can say that efficient way? That obviously we are expecting based on the response time. And whenever, as we know that there are so many number of users are there, whenever if I am accessing the required data is supposed to be in a consistent way. I have to maintain which is in the form of the consistent way. So these views, these different types of the views, it provides the perspectives to the users, or otherwise we can say that it creates a sophistication to the users to in a convenient and efficient way to access the respective data on the database. Right? I hope you are clear about what is the reason we are going for the views. Since because of the nature of, I want to hide the certain details to the various number of the users about the database. Correct? So let me go to the data abstraction. So whenever if we are defining any system, obviously it's supposed to be usable. Right? So when we want to use very often on any particular system, it means that that application or that database is convenient for me to use it under varieties of these. So in a simple way, it creates a sophistication to access or to retrieve whatever I want. To access or retrieve whatever I want. So this retrieval of the data is supposed to be effectively and the efficient manner we have to do it, even though it is there in the even though if it is on a complex data structure. Why? What is the reason? Because many of the database users, whichever we have defined, they are not computer trained. But whereas the DBA, the database administrator, they are having they know the complete details of the entire skeleton and structure of the database. Okay. So because of this, I need to hide certain complexity from the users by using the various levels of abstraction. With this, what I am trying to do is, that is, to simplify the user interactions with the system. In turn, by achieving the efficiency and having the various levels of abstraction. Right? So this I am going to name as the views of the database. The first one, which I said, that is called as the physical view, that is a lower level abstraction. Now, this level, we can understood how the data are stored on the particular storage medium, in which format it is stored, what is the data type, what is the size, and whether it is stored in the continuous way, contiguous way, or in a sequential way. All these things we will come to know with the help of this physical level. And also this physical level describes the complex low-level data structures in detail. In briefly, it explains about, it describes about the data structures what we are going to follow here. Right? Obviously, these details are not needed at the end user's perspective, not necessary to know at the end user's perspective. Right? And next is a logical level. The next higher level, that is called as the logical level. So in this logical level, we will come to know that what data are stored in the database, what type of data are stored in the database, and what is the relationship among those data. This is very, very essential. If we come to know this relationship of the various data and the database, then only any application programmer, they can use the programming languages, they can use any programming tool to retrieve the respective data, or to access the respective data. So this logical level, it provides or it gives the clear-cut relationship among the various data which is associated on the particular database. It is associated on the particular database. This logical level, as I said, this logical level, it describes the complete database by using the simple structures. Now, the complexity is little bit reduced on the higher level. The complexity is little bit reduced on the higher level. So, by using the simple structures, every database have to be represented to the users. Now, what is the reason I should have on the logical view, I should have the structures? Because I am handling with the very complex physical level structures. Now, whoever is accessing this logical level, they need not to aware of this complexity, physical level complexity. Because of this reason, I am going with the simpler structures on the logical level. Right? Clear? So, this is called as the physical data independence. This is called as the physical data independence. Since I want to represent the complex data structures onto the higher level or onto the next level, so I am trying to hide certain physical information, or I am trying to hide certain complex physical structures and replacing those complex physical structures, that is dividing those complex physical structures onto the simpler way by using the simpler structures. So this process is called as the physical data independence. Right? So every database administrator, they must decide what information to be keep in the database, because it defines what is the data is going to be stored, and it is a relationship is also going to be defined. So whenever On the logical views perspective or the logical level abstraction, the database administrator have to decide what type of information I have to store it on the particular database. And they also need to define what is the relationship among the each and every data associated on the database. So this is called as a logical level. And next is called as a view level. So view level is obviously which is are used by the end users. That is for the end users, which is having the high level of abstraction. And also this view level is going to be performed only on the part of the DB, part of the database, not to the entire database. Why? What is the reason? Because every individual end user players are having their own role. Right? Say for an example, in an industry, if you have an employee database, the HR will look only onto the certain aspects on the particular database. They need to calculate the attendance, and based on that the salary will be processed, and intensive and yearly increment supposed to be processed. But whereas on the project manager, they will have the complete details about the particular project, not on the entire project which is running under the company. So that way I say, so every users they are having end users they are having the different views, different levels. So a system supposed to facilitate the different levels of abstractions to the various users. Because of this nature only they are accessing the part of the DB. Right? And this logical level which uses the simpler structure, it doesn't mean that the complexity of the database is reduced. No, the complexity remains the same. Why the complexity remains the same is because of the wide variety of the massive amount of interconnected or interrelated data are stored on the particular database. Right? But according to the hiding of various complexity level, it creates the illustrations to the users stating that the structure is very, very simple. Only as being the end user's perspective, I need to access the our university database for only marking the attendance and retrieving your attendance percentage. That is the one purpose. In this case, if the system is complex to make the attendance entry as well as also to retrieve the attendance report, then obviously no one will access the respective thing. No one will access the respective database. That way it hides the complexity, but the complexity remains the same. Right? So another one thing for the view level is, since many users are on the particular database system, obviously they no need of all the information. They need only the particular portion of the database. Right? So what we can get from this view level? So this view level of abstraction is there to simplify the interactions with the systems. Obviously, as being the end user's perspective, every developer are thinking on the same aspect. We need to create a sophisticated and convenient environment to the end user to access or to utilize the system. That was done in the view level. Right? So This is a typical diagrammatic representation or the relationship of the various three levels. The lower level, which is called as a physical level, is a lower level. And this is a higher level, and this is another one higher level. See that I have from this diagram, we can easily understood that why the views level are only having a various number of sub-views. Why not it is in the logical level and then physical level. So these all are is going to define the schema, the structure of the particular database. Whereas there are so many end users are trying to access this schema. Now all the end users are need not to necessarily to know the complete structure of the database. Only this should know only the part of the DB. Only they should know the part of the DB. Right? So because of this nature only, the view level is having the various sub-views. The view level is having the various sub-views. I hope you understand what is called as a physical level, physical view, or and the logical view and the view levels. Right? All this, the simplest way, if we want to talk about the views, I want to hide the complexity of the databases to the different users. That's why I'm moving on to the various levels, abstraction levels of the particular database, of any database. Right. Let me go in detail. So this view level, which is similar to the concept of the data types in the programming languages. Because for every data, it is based on the different data types. It is based on the different data types. To support this, we need to use the notation that is called as a structured type. We need to use a notation that is called as a structured type. Right? Here, one of the example of the structured type which is called as a record. So in the DB, we are using the record. So this record is, as a programming perspective, this is one of the well-structured type. This record is having a record name and it has the various attributes or the various fields or the various entities. So this is a simple example. I have a record. I am maintaining one record, that record which is called as an inspector. The name of the record is called as an inspector. Every inspector is associated with so many other attributes. So every inspector is having their own ID. Every faculty is having a own ID. Every non-teaching faculty members is having a own ID. They are having the name and they are having a own department name and the salary. See, in this a single record, in the single record, we are storing the different data types. Different data types. This is for only single record. If you come with the collective of massive amount of a database, the number of data types is also increased. That's why the complexity level is also increased. And looking on the schema's perspective, why the complexity level is increased? Because there are so many interconnected, interrelated data. Right? And this is for the university record. The university have to maintain the on the university database. We have a department database and we have a course database and we have a student record. We have a department record and we have a course record and we have a student record. Alright. Now at the physical level, That is on the physical level, physical views. Now, how on the whatever the records we have seen, how it is stored on the storage location. It defines how it is stored on the storage location. Right? And on the physical level, it hides, the compiler hides this level of details from the programmer. Which level? These storage levels are hidden to the programmer. Right? So the database system hides many of the lowest level storage details from the database programmers. Yes, absolutely. Then only the programmer can easily write the program and for accessing or retrieving certain data from the database. Now, only these database administrator DBAs are authorized to know or aware the complete details of the structure of the particular database. Right, at the logical level. So at the logical level, every record we have to maintain. So every record, that simpler structure we are going to maintain here. The simple structure we are saying that it is a structured type. So that is called as a record here. So every record is having its own definition. Every record is having its own definition. Instructor record is having its own definition. And it also defines, not only the definition, it also defines the relationship among the data. Likewise, we have a department record, student record, likewise, etc. Right? So, if we have a structured type, then it is easy for the programmer to use certain programming tools to access the particular database, or whatever the operations they want to do, they can easily perform, even though whatever level of abstractions they are having it. Right? And next is ten minutes. 10 minutes. So the database administrators usually work at this level of abstraction. Right? Okay. Next is the view level. So view level is the computer see as a set of application programs that hides the details of the data type. Because I don't want to know the data types and other things. Okay. So these are the things which is related to the view level. Since I have given one example, this already I have quoted this. For example, a clerk in the university and the registrar office, university registrar office, she is authorized to access only the particular part of the database. Now this abstract level, this view level is not only for hiding the data, it also provides the security mechanism to prevent the unauthorized access. So we can say it is a role-based access. Now this clerk need not to access the salaries of the each and every inspector. So those details are hidden to the respective user by using the various security mechanisms. Right. Let me move on to the next thing, that is called as the instances and then schemas. Because when we are talking about the view levels, we should know what is called as the instances and as well as also the schema. Schema, as we know, schema is that is called as the complete structure of the particular database. Whereas the instance is, we know that the database is having the collection of a data. Every data, it holds some value at a particular moment. When you are writing a program, it have a various number of data types are there. Every variable, it holds At a particular moment, it holds certain values. So that is called as instances. That is called as instances. So the collection of information stored on the database on the particular moment. And the state S1, the variable or the database holds this value. So that is called as an instance. That is called as an instance. Then overall design, that is called as a database schema. Right? So these all, whichever I have said, the same thing is repeated here. So the database systems have several schemas which are partitioned according to the levels of abstractions. So the physical schema, it describes the database design at the physical level, whereas the logical schema, it defines the database design at the logical level. Right? So a database may also have several schemas at the view levels, because there are so many number of end users, they are trying to access the part of the database. So that is called as subschemas. That's why we have the various number of views on the particular view level. Right. So the logical schema is most important, is because of based on this level, that programmer is constructing the applications to access the particular database. The physical schema is hidden under the logical schema. So we can easily change it without affecting the application program. The physical schema details we can easily change it without affecting the application programs. Right? And data models. There are the 4 data models are used widely. One is called as a relational model. Second one is a ER model. That is a entity relationship model. And third one is a object-based model. And a fourth one, which is called as a semi-structured model. So our database, whatever the DB which we are going to create, which is based on any one of the model here. So the schema, when we want to know about the structure of the schema, we should know the data models. That's why I kept these data models after the defining the instances as well as also the schema. How to represent the data by using the data models? In one point of time, as I said, that a logical view, it defines how to store, what information is supposed to be stored, and what is the relationship, how supposed to be achieved. That is going to be done with the help of the data models. Okay? So it is a collection of conceptual tools for describing the data and to define the relationships and to define the data semantics, and main thing is consistency constraints, because the varieties of users are trying to access a particular database. So a data model, it provides a way to describe the design of a particular database on the various levels. So it can be categorized into 4 ways: relational model, entity relationship model, object-based model, and semi-structured model. Let me go in detail one by one the relational model. Anyway, then later topics it covers in detail of all these things. Now just I'm giving the abstract view of what is relational model. this relational model, it uses a collection of a tables. What is the reason I am having a table is to represent both the data as well as also the relation. That's why it is called as a relationship model. So from this data model, we will come to know what is the relationship of the particular data. Alright, each and every table will have a multiple columns, which is having a unique name. As I said, the inspector database, inspector record. Right? Now this table is called as a relation. The tables are also known as a relation. So this is based on the record model. Why this is based on the record model? What is the reason in behind of that? Because of it is a fixed format. It is a simpler structure. We are representing this relational model as a record-based model because of the reason is behind is the record-based model is a fixed model. It is easy to structure. So each table contains a record of a particular type. Yes, absolutely. Inspector is one record. It have a fixed fields are there, that is called as attributes. Every table is having its own rows and columns. It will be like rows and columns. So this is the example of the relational model. This is a complete table. So this is a relation. This relation name is called as a student relation. It have a various attributes. The column values are called as attributes or the field. And every relation is having a row. So the row is called as a tuple or a record or the entity. Right? So this is called as a relational model. Whereas the entity relationship model, now here we are using on this ER model, we are using the collection of basic objects, that is called as the entities. Based on this, we are deriving the relationship. Right? So this is an example of the same thing I am converted onto the different model, another one model, that is called as the entity relationship model. Here the relation name, the database name is called as the model. In the database is a student and their addresses and their details. That is, these are the attributes of the particular table. And once again, this address, it have so many other components. So this is the relationship. So it also defines the relationship. So every object is identified by using some real world entity. Right? The object model. Same thing is the relational model. It combines the features of the relational model and added with the other object-oriented programming concepts, polymorphism, inheritance, and encapsulation. So everything I have to added into this relational model. Then we have derived the new data model, that is called as object-oriented data model. Right? This is the way to represent the object-oriented data model. Everything will be deals about the objects. Objects, functions, like this. So it is the it combines the features of the relational model and then object-oriented programming. Why? What is the reason of this object-oriented model we want to study is because of the predominantly we are using these object-oriented languages on the software development. That's why the object-oriented model, database model is also become a popular. So next is called as a semi-structured model. The semi-structured model, it permits the specification of a data where individual data items of the same type may have a different sets of attributes. This is called as a semi-structured data. So now the semi-structured data is represented by using the XML, languages. The same type of a variable is having a different attributes that can be done with the help of the defined with the help of the XML. Okay. So with this, I'm stopping my presentation. I hope whichever I said so far about the views of the database which are clear. If you have any queries, kindly go through the presentation. If you have any queries, you please feel free to ask your queries.